All right, so get this. We're going way back to a time when people thought our eyes worked like uh, little searchlights beaming out light to see.
You're talking about the emission theory of vision.
Yeah. Can you believe that?
Hard to imagine now, isn't it?
It is. But then along came this incredible guy, Ibn al-Haytham, and he totally changed the
He
game.
really did turn everything upside down.
For real. And that's why we're doing this deep dive, ready
Yeah.
to unpack why he's known as the father of modern optics.
Absolutely. I think it's going to be a fascinating journey.
Right. We've got all your excerpts on his life, his work, all that.
Yeah, it's amazing. Not just optics. I mean, he was a real polymath.
Oh, yeah?
He was into math, astronomy, even philosophy. Like, you name it, he was interested.
Wow. A true Renaissance man, centuries before the Renaissance. Okay, so to set the stage, he's born in 965 AD in Basra, Iraq.
Right in the heart of the Islamic Golden Age.
Exactly. Think like libraries overflowing with knowledge, scholars from all
A
over.
real vibrant intellectual scene.
The perfect place for a mind like his to flourish.
Definitely. And he was super curious from a young age. Like, he was really into science and math, even as a kid.
Must have been a pretty nerdy kid.
He was all about figuring out why things work the way they do.
So he was more than just like good at math. He actually wanted to understand the natural world.
Yeah, go.
That makes sense. So that thirst for knowledge takes him to Cairo, which was kind of like the intellectual hub of the world back then.
It was the place to be if you were a scholar.
Exactly. And Ibn al-Haytham, he quickly makes a name for himself. He even gets like government gigs, right?
Oh, yeah. He put his knowledge to work on some pretty big problems. Like, there was this challenge to control the flooding of the Nile River.
Oh, wow. That's a huge deal.
It was a massive engineering project, way ahead of its time.
So did he succeed?
Well, he proposed building a dam, but the technology just wasn't there yet. It wasn't really feasible.
So what happened? Did they like punish him for failing?
Well, to avoid that, he did something pretty wild. He pretended to be insane.
Whoa, are you serious? He faked madness.
Yeah. It was a risky move, for sure.
That's crazy. So did they lock him up?
He was put under house arrest.
Oh, wow. So not exactly freedom, but
Ironically, that house arrest was a turning point. It gave him the space to really dive into his scientific work.
you're kidding. So like being forced into isolation actually helped him focus.
It's kind of amazing, right? That's when his groundbreaking work on optics really takes off. He starts questioning those old theories about how vision worked.
You mean the whole searchlight idea?
Exactly.
Yeah.
He wasn't content just accepting what everyone else believed.
Yeah.
He wanted to test it, challenge it.
And he ended up proving it wrong.
That's right. He demonstrated that we see because light enters our eyes, not the other way around.
That seems so obvious now.
It does, but it was a monumental shift in understanding back then.
Yeah, that's true. So he figures out how vision actually works.
And then he goes even further.
Really?
He starts experimenting with light itself. And you know what he stumbles upon? The camera obscura.
Ah, the pinhole camera. I remember reading about that.
Yeah, it wasn't just a cool invention. It was like a key piece of evidence for his theory of vision.
It's like a light bulb went off, right? He realized, wait, this proves how light travels.
Exactly. Light travels in straight lines and forms images. It was a huge breakthrough.
Wow, so much came from just like a dark room with a tiny hole.
It's pretty amazing, right? How curiosity can lead to such groundbreaking discoveries.
Speaking of groundbreaking, we've got to talk about his contributions to, well, science itself, the scientific method.
Right. He didn't just make discoveries. He revolutionized how we think about knowledge.
So he wasn't just a scientist, he was like a philosopher of science, too.
Absolutely. He stressed the importance of observation, experimentation, really rigorous testing.
He was all about proving things, not just guessing.
That's a great way to put it. He wasn't satisfied with just coming up with ideas. He wanted to see them in action, to gather evidence.
Don't take my word for it, he'd say. Test it yourself. I love that.
Yeah, and that's why his influence is still felt today. He basically set the gold standard for scientific inquiry.
And this is all from a guy who was under house arrest. Talk about turning a negative into a positive.
He definitely made the most of a difficult situation.
Welcome back. Last time, we left Ibn al-Haytham kind of stuck.
Under house arrest, but
Yeah, but it turned out to be a pretty productive time for him, huh?
you could say that. It's like freed from all the distractions. He could just,
Focus.
yeah, exactly, focus on his work.
And speaking of his work, let's get back to his theory of vision. This idea that we see because light comes into our eyes.
Not out of them.
Right. Like, before that, people thought our eyes were, like, shooting out beams of light to illuminate things.
It's wild,
I
right?
know. Like, we had little flashlights in our heads or something.
It was called the emission theory. And even, like, brilliant minds,
LaCroix.
Ptolemy,
Oh, yeah.
Euclid, they all believed it. Wow. They thought light was coming from us, going outward. Yeah, illuminating everything around us.
But Ibn al-Haytham, he was like, wait a minute.
He started noticing things that just didn't fit with that idea.
Like what?
Well, he was a really sharp observer.
Uh,
And he realized that, like, looking directly at the sun hurts.
Makes sense.
Right. And it can even damage your eyes.
Okay. Yeah. So his point was, if our eyes are the ones emitting the light.
Why would looking at another light source be a problem?
Yeah. Shouldn't it just add more light, not hurt?
Exactly.
It's a simple observation.
But it's a huge challenge to the whole theory.
It's like one of those things where, you've believed something for so long.
And then suddenly you see it differently.
Yeah. Like, duh, why didn't I think of that before?
Exactly.
So how did he, this is way back in the 10th century, right? How did he prove his theory?
Through experimentation. Careful observation.
But like no fancy labs or anything?
No. But he did this experiment with light passing through a small hole.
The camera obscura thing.
Yeah. He noticed it formed an upside-down image on the wall.
Oh, I see. So that was more than just like a neat trick with light.
It was a key piece of evidence. It showed how light traveled in a straight line.
Ah, and that's how the image forms.
And it supported his idea that we see because light enters our eyes, not the other way around.
That's amazing. That one shift in thinking.
It completely revolutionized optics.
It's the basis of everything we know about light and vision today.
Pretty much.
And we can't forget, his whole approach to science.
The scientific method.
Right. That's huge. He emphasized things like testing, observing, actually proving your ideas.
He was all about systematic observation, rigorous testing.
Not just like making guesses.
Yeah, not just philosophical speculation. He wanted evidence.
So he wasn't just like a scientist. He was also like a philosopher of science.
Totally. He shaped how we think about knowledge itself.
That's a pretty big deal.
He was like, don't just take my word for it. Test it out yourself.
I love that. So he figures out how vision works, right? But he doesn't stop there. He starts digging deeper into, like, the properties of light itself.
Exactly. Things like reflection and refraction.
Okay. Those words always make me think of, like, high school physics and,
Oh, don't worry. It's not that complicated.
Yeah. Well, I hope not. But seriously, can you explain those just so everyone's on the same page?
Sure. Reflection, that's just when light bounces off a surface. Like a mirror, you see your reflection.
Because the light's bouncing back at you. Okay, that makes sense.
And refraction, that's when light bends as it passes from one, like, medium to another.
Medium.
Like from air to water.
Oh, so that's why a straw looks bent in a glass of water.
Exactly. The light bends as it goes from the air into the water.
That always seemed kind of magical to me.
It is pretty cool.
Yeah.
But Ibn al-Haytham, he didn't just want to, observe these things. He wanted to understand them.
To figure out the
The
rules?
laws, yeah, how they worked.
So he's like, a light detective.
He wanted to quantify them. Turn them into equations, laws.
Wow. So what did he find? What are these laws of reflection and refraction?
Well, he demonstrated that the angle at which light hits a surface, it's equal to the angle it bounces off at.
Oh, like, when you bounce a basketball. The angle going in is the same as the angle coming out.
Exactly. And with refraction, he showed how the bending depends on the density of the materials.
Oh, okay. So air is less dense than water, so the light bends more when it enters the water.
Right. And that's the principle behind lenses, which are used in, eyeglasses, cameras, telescopes.
So again, his work leads to all these technologies we use every day.
It's pretty incredible.
It is. It's like he laid the groundwork for, like, modern optics.
But his impact goes way beyond that. His scientific method, his emphasis on evidence, that's huge.
Yeah, that's a legacy that goes beyond any one specific field.
It's how we approach knowledge, how we solve problems. He was a true pioneer.
And all of this while under house arrest.
It's a testament to the power of the human mind.
For sure. All right, so we've covered a lot of ground, right? Ibn al-Haytham's work on vision, light, even his whole approach to science.
Yeah, he was a remarkable thinker.
He was. But now I kind of want to look ahead. What's his lasting impact? Like, how does his work still matter today?
Well, his influence is everywhere. Just think about the field of optics. His discoveries literally changed how we see the world.
Okay, so let's break that down. What are some specific things that we can, like, point to and say, that's because of Ibn al-Haytham?
Well, for one, eyeglasses. His understanding of lenses, how they bend light, that paved the way for eyeglasses. I mean,
Wow, yeah. Before that, if you had bad vision, you were kind of stuck.
pretty much. But thanks to his work, millions of people can see clearly.
It's amazing, right? It's something we take for granted now.
Totally.
And what about photography? I mean, we talked about the camera obscura.
Right, that was a crucial step towards the modern camera, understanding how images could be formed, captured.
Yeah, I mean, imagine a world without photography. No pictures, no movies.
No selfies.
Exactly. It's such a fundamental part of our lives now. And speaking of expanding our vision, what about astronomy?
Oh, huge impact there. Telescopes, I mean, they wouldn't be possible without his work on lenses and mirrors.
So he helped us see farther into space.
Literally. He helped us see beyond what's visible to the naked eye. We can explore the universe thanks to him.
It's mind-blowing, you know, from tiny things under a microscope to the vastness of space, all because of his work.
It really shows the power of his discoveries.
But it's not just about the specific inventions, right? It's his whole approach to science.
The scientific method.
Yeah, observation, experimentation, proving your ideas.
Rigorous testing, challenging assumptions. That's his legacy.
It's like he gave us the tools to understand the world, a set of rules to follow, to make sure we're not just guessing.
And that's why his influence goes beyond science. Those principles, they apply to everything.
Critical thinking, problem solving.
Exactly. In a world with so much information, knowing how to evaluate evidence, how to think for yourself.
That's more important than ever.
Absolutely.
Yeah.
And it's all thanks to this, scholar from the Islamic Golden Age. His work has shaped Western science.
And he continues to inspire people all over the world.
It's a reminder that knowledge, it transcends borders, cultures. We're all connected.
It's a pretty powerful legacy.
It is.
Well, I think we've given Ibn al-Haytham his due, right? Explored his life, his work, his impact. It's amazing to think about how one person's curiosity
Can change the world.
Yeah. So, next time you put on your glasses, take a picture, look up at the stars.
Remember Ibn al-Haytham.
The guy who changed how we see everything.